You know that simple button you tap on your phone when you're hungry? Well, it turns out it's not so simple. It's actually a doorway to one of the most complex, high-speed logistics engines ever built. Today, we're going to pop the hood and see the incredible tech that powers every single Swiggy order.
So picture this. You're on your couch, you finally decided what to eat, and you tap that button. For you, the hard part's over. But for Swiggy systems, the show has just begun. You've just kicked off an absolutely massive technological ballet.
And I mean massive. In that single instant, more than 400, that's 400 different microservices roar to life. Think of these as hundreds of tiny, specialized programs, each with one specific job, that have to coordinate perfectly to get that meal from the kitchen to you.
So, let's start where your journey begins, the app on your phone. This is your portal into Swiggy's universe, and their very first challenge is making sure that portal is unbelievably fast and smart.
I mean, just think about everything the app has to show you at once. Restaurants, menus, deals, your own profile. If your phone had to call up each of those 400 services one by one to get that info, the app would be painfully slow. In the tech world, they call this problem chattiness, and it is an absolute user experience killer.
So how do they get around it? With this really elegant solution called a backend for frontend, or BFF. And yeah, it really is your app's new best friend. Instead of your phone making all those different calls, it just makes one single smart call to the BFF. The BFF then works like a personal shopper. It runs around, grabs everything the app needs from all the different services, and packages it into one neat little bundle to send back. It's way faster, super efficient, and it even saves your phone's battery.
Okay, so the app is fast. Great. But is it smart? In a country as diverse as India, one dish can have dozens of different names. This creates what's called a vocabulary mismatch problem. How on earth does the search bar know what you really mean?
The answer is some pretty powerful AI doing what's called semantic search. Now, this is not your old-school keyword matching. This tech is designed to understand the context, the vibe, the real intent behind your words. It's all about meaning, not just letters.
So here's the cool part. Swiggy has trained these AI models on millions and millions of past orders. The AI has learned that when people search for veg rice, they often end up buying pulao. It then plots all these words in a kind of virtual universe. In this universe, words with similar meanings, like our pulao and veg rice, end up floating right next to each other. So the system doesn't just see what you typed, it sees what you're getting at.
So, your order is in. The app has done its job. Now the baton gets passed to the true powerhouse of the whole operation, the core logistics platform that's about to orchestrate this entire delivery. Now, what Swiggy is trying to solve here is what computer scientists call an NP-hard problem. And all that fancy term means is that the puzzle of assigning the perfect delivery partner to the perfect order at the perfect time has so many variables that finding the single best solution would literally take forever. So the real game isn't finding the perfect answer, it's about finding a great answer in milliseconds.
To even attempt this, Swiggy had to completely rethink their system. They broke it down into this flexible three-layer cake. At the bottom, you've got your basic utilities, things like maps and notifications. The middle layer is the magic. It's a generic logistics platform that just knows how to move stuff. Then on top, you have the specific business rules for food or groceries or whatever's next. This architecture is what lets them spin up totally new delivery businesses at lightning speed.
The key to that middle layer was breaking a delivery down into abstract little building blocks. A task is the smallest possible action, like go to this address. A job leg is just a string of those tasks. Because it's so abstract, the system can get creative and do complex things like batching orders, where one driver picks up 2 different meals without needing a whole new set of code.
But a logistics brain is totally useless if it's blind. It needs eyes on the ground. And that brings us to the next monumental challenge. How do you track an absolutely enormous fleet of delivery partners in real time? And I mean, enormous is an understatement. We're talking about a fleet of over 300,000 partners, just trying to process the location of every single one of them every few seconds across cities with good and bad network coverage. Well, it's a data challenge of staggering proportions. So the normal way websites talk to each other, HTTP, is just too bulky and slow for this. It's like sending a giant package when all you need is a tiny node. So Swiggy uses a different protocol called MQTT. It was designed for tiny, smart Internet of Things devices, so it's incredibly lightweight. It keeps one connection constantly open and just trickles these tiny location updates. It works like a charm.
even if the partner's phone is on a really weak network.
Okay, so we've got a fast app, we've got a smart brain, and we've got eyes on the fleet. But how do you stop this entire intricate house of cards from collapsing the second one little piece breaks? Well, this is where you build for resilience.
And this is the core philosophy you have to embrace. With hundreds of moving parts, something is always going to fail. It's just a fact. So the goal isn't to prevent every single failure. That's impossible. The real goal is to build a system that expects failure, shrugs it off, and just keeps on going. An anti-fragile system.
They pull this off with a concept called graceful degradation. Let's say the service that handles discounts goes offline. The whole system doesn't crash. No, it just shows you the menu without any discounts. You can still place your order. Or if the live tracking map breaks, the app will just give you a smart estimate of where the driver probably is. The most important thing, the core experience of placing an order is protected at all costs.
The system also has to deal with pure chaos. You know, when it starts pouring rain and suddenly everyone in the city decides to order in at the exact same time. To handle these insane spikes, Swiggy uses a really clever auto-scaling tool called CADA.
And the difference in approach here is just brilliant. Most systems are reactive. They only add more power when their servers are already getting overwhelmed. That's too late. Swiggy's method is proactive. CADA doesn't watch the servers, it watches the length of the line of people waiting to place an order. As soon as it sees a crowd forming, it starts adding more server capacity before the system even feels the strain.
So, when you step back and you look at all these pieces together, the smart interface, the massive logistics brain, this anti-fragile foundation, you start to realize something really important about what Swiggy actually is.
They're not really a food delivery company anymore. What they've actually built is an incredibly powerful, general-purpose engine for on-demand convenience. This is the playbook for the modern platform company. Don't just solve one problem, build a machine that can solve an entire class of problems. In this case, the problem of moving anything from point A to point B really, really fast.
So, the next time you tap that button, just take a second to appreciate this symphony you've just conducted. There's a BFF proxy making everything feel instant, an AI that understands what you're craving, an algorithm solving a problem that would stump a supercomputer, and an entire system designed to just dance in the chaos of the real world.
Because really, the tech we've just talked about isn't just about getting dinner to you faster. It's a blueprint for the future of how our cities operate, a model for solving huge, real-world coordination problems. Which leads to one final exciting question. If a button can solve hunger tonight, what other massive, complicated challenges are going to be solved by